Okay, welcome to the February 1st episode of the BenMore Brief. Today we have a guest joining us who I'm sure will come back quite often. My former teammate at BU. What is your position at Jeani Health? CTO?
Yeah, co-founder and CTO.
Co-founder and CTO at Jeani Health, Wearable, an AI wearable tech. You'd be best to describe it, actually.
Yeah, well, we consider ourselves a new kind of wearable company focused on movement health rather than cardiovascular health would be the really high level description.
And right now, you guys just recently launched an Apple Watch application, correct? And a mobile application. It's just in the Apple ecosystem at the current point, right?
At the current point, that's right, yeah. And we have ambitions to expand to Garmin, which I'm wearing one right now, and ultimately to make our own.
Nice. And so, walk me through specifically, let's say you download the Apple Watch application, you get the mobile, application. What's the immediate, benefit? Walk me through exactly what, someone could do and, how the value that it could bring to their sort of day by day, or, I know you guys do a lot of stuff in athletics, after downloading the app.
Yeah, sure. So right now you could go to the App Store, download Jeani, and go outside, take a 5-minute walk. It's as simple as that. And then we'll give you insights into the health of your hips, your knees, and your ankles. We have ambitions to do every muscle and every joint in the body, but right now that's the level of sort of accuracy we're comfortable releasing. But I myself have found this immensely helpful. I train sort of in Division 1 track and field, and I've had hip surgeries on both hips actually. So monitoring the kind of health of those joints is really important to me, as knowing when to push through and when to kind of dial back the load. But this kind of applies to everyone, right? Hips, knees, ankles, backs. These are all things, actually, I don't need to tell you this at all, because I know you've had kind of your own struggles with post-athletic pain, but kind of writ large, chronic pain is a hugely debilitating condition to adults around the world. And so our mission is kind of to solve that.
Very interesting. And right now, I know you guys just launched. What are some emerging use cases you guys are seeing? Is it, I know we talked, separately about, potential elder care use cases might be extremely helpful. But what are some emerging use cases that you're seeing, and what early feedback are you getting?
Yeah, it's interesting. So we have kind of, because of the nature of what we do, we've kind of considered this an injury prevention device, right? But what we're actually finding is when this is getting in people's hands, the way people are using it is actually more of a tracking platform. And because we're an AI native company, we hook up all of the data to an LLM system. It's really helpful to be able to say, hey, what's the relationship between how hard I push in training and my left hip? How does that affect it? And you'll find that, some joints are really closely correlated with kind of your level of intensity, and others will be completely inversely correlated. And so that's really helpful for knowing if something hurts, what do I actually do about it? Rest isn't a panacea. Sometimes it is important to rest, but sometimes you actually need to kind of go out and do that movement. The movement is the medicine.
Interesting. That kind of segues me into sort of the main question. And, we've talked about this. You have a background in AI. You're currently in the master's program over at Duke, and you're getting a degree specifically in AI. Or is there a concentration?
That's right. Or? Yeah. No, it's just the AI program.
So, it's one of those things where it's if you understand technology, you can definitely see a path where, predicting patterns over time from, your wrist motion could make sense. Stranger things have been done in technology that are sort of, interesting. But I would say, my opinion is to your average consumer, just, analyzing the movement of your wrist, because that's essentially where the device is, right? Sort of this swinging motion. Can you just, sort of explain some of the underlying technology that allows you to derive through sort of this movement right here, and how you can extrapolate that into, as you mentioned, hips, knees, etc. That's very interesting to me.
Yeah, it's pretty awesome. The way that we like to think about it is it's pretty obvious to even just the human eye. If somebody's knee is completely shot, you can see them limping, right? And you can see the disorder in the motion. And And what we really found is that that scales down. So when somebody has sort of micro damage in these different joints, their movement is affected in sort of very subtle ways. And what we've done is trained sort of large machine learning models to pick up those kind of small changes in your movement patterns. And when we do this, hundreds of times a day across many, many days, the accuracy, it compounds and goes up and up. And so really what we're looking for is these kind of like micro limps.
Mm-hmm. Got it. And you can get that from walk me, I've never built wearable technology, but I assume all the data is coming from sort of this swing. But I mean, it makes sense, right? If someone has a limp, this motion is going to be janky, maybe off a little bit, it's not going to be direct, you know what I'm saying? But is that generally correct? Like you can tell from just the wrist movement, and sort of identify, for example, if you're limping on your left knee and you're wearing the device on your left hand, right, then there's going to be like a sort of like a hit, right?
Exactly.
Like,
there's
about
sort of kind of like little jerks in the movement, kind of how the because what we really do is look at the accelerometer and kind of what the movement of your wrist looks like as you're walking. And we know what normal movement looks like. We know what people with dodgy knees, what that movement looks like. And so you can kind of imagine that we're just pattern matching to what we've kind of seen in the training data. Interesting.
And this does seem to be, you have a data play here as well, where essentially this seemingly to me will only get better with more users, with more data to sort of derive insights from, and you'll be able to nail it really down like long term outside of what you've been able to initially train on, correct?
Yeah, my kind of hobby horse is the scaling laws applied to wearable technology, right? So people talk about, when a new AI model comes out, people are like, you realize this is the worst that AI is ever going to be. And this is true for our models as well, right? This is the worst they will ever be, because the more data we give to them, the larger we can make these models, the more ambitious we can be about predictions. So we want to do every muscle in the body. We want to do every joint in the body. We want to do predictive analytics. We want to be able to tell people, scale back your load or you're going to tear your hamstring. That's the sort of ambition that we have. I wrote an essay, I think a week ago now, called Wearables of Loving Grace, a little homage to my goat, Dario Amadei. But really the call to action is that the scaling hypothesis has been the most successful paradigm in technology of the last 10 years, full stop. Let's apply that to wearable technology. I really don't know why we haven't done it yet. We can be so much more ambitious than just, here's your sleep score, here's your resting heart rate.
Heart rate, right? Yeah,
exactly. We need to be way more ambitious.
That's true. So other wearables, they're just sort of more on the diagnosis side. I'm not, I don't know anything about that space. As you know, I patently rejected wearing wearables back in college, but they're more so on the diagnosis, simple monitoring. Is that what's going on? They're not really given insights, or what is the space?
They are fantastic platforms for cardiovascular health. I wear an Oura Ring, I wear an Apple Watch. I'm actually currently wearing a Garmin as well. I love wearable technology. They are fantastic platforms for cardiovascular health, but the reality is that's one system in an immensely complex system that we call the human body. So we need to kind of progress beyond just this kind of cardiovascular paradigm. Don't get me wrong, the current platforms are amazing, but to me, it looks like their ambition is more cardiovascular into the kind of medical grade technology. And that makes a lot of sense, right? That's a huge TAM. That's loads of money.
Right. Most people die because of, heart disease, to my understanding.
Right, exactly.
So,
and integrating with medical systems is you have to have huge amounts of money behind you, which these kind of incumbent wearable companies do have now. So it makes a lot of sense. But we're going to need startups and kind of other players in the wearable space to push these other paradigms forward. Movement health, perhaps continuous glucose monitoring, and probably many others that I haven't thought of.
Do you have any competitors in the space that you've identified?
We don't really. It's interesting. So there's Fort Health. They're making a wearable for strength training, which we're not. I don't think I would consider them a competitor. They're sort of adjacent to us, but we consider ourselves more of like a movement well-being / health company, and that's pretty niche. So I don't know. We don't really have any competitors at this stage.
Got it. Okay, interesting. So you developed the core platform. I know you were doing a lot of coding yourself. This is a nice little segue into the agentic coding and your usage of the tools, essentially with your expertise and background in AI. How have you utilized agentic coding? Because you were neuroscience major, and did you double major in college?
I did, yeah. Neuro and econ, yeah.
Neuro and econ. But you've developed this platform from the ground up yourself, coding with relatively limited formal training in coding. And I remember you were one of the first people to tell me about Claude Code. Walk me through your experience essentially utilizing from a non-formal training in coding, utilizing agentic coding to build the platform. How's your experience been there?
Yeah, it's interesting. I was talking to someone about this the other day. It's weird that we are probably the last generation that learned to code manually. At least since December, I haven't written any code by hand. Sure, going into the code itself and correcting a few lines here and there, and obviously bugs come up and that happens, but I can't think of any projects, and we work on pretty ambitious stuff, right? We're training our models from scratch, and there's no world in which it makes sense for me to write the code out manually. I can give extremely detailed kind of prompts, but it's so much faster to prompt, review, and fix than go from the ground up myself. This hasn't always been the case. Like, I think about this time last year, agentic coding was really fun, but maybe not that useful, in that you could produce a lot of code really, really fast, but actually a lot of it would be tech debt, not useful, and full of bugs. And it was probably marginally faster still to write it by hand, even if it was obviously a lot less fun. And that was kind of the era that Cursor was like the product, right? Because you could see the code right there. You had the AI window, but it was much more hands-on. Moving, I think probably everyone thinks of the turning point being like Opus 4.5. I would even say maybe Opus 4 for me was really when I stopped.
For me, it was Sonnet 3.7, yeah.
Right, exactly. Yeah. But that was when I stopped looking at sort of every line of code and really relying on it more. What's more important now is testing, because it doesn't make sense to read all of the code. And actually, I'll share an interesting story. So in our first build out of the back-end system, we used full TypeScript. It's a great language and platform. Yeah. But when we came to rewrite a lot of the stuff, I actually decided to rewrite it in Python, which is obviously a lot slower.
Flask?
Yeah. It's a lot slower and it's less sort of scalable than TypeScript, but it meant I could read code that AIs produce much, much faster, debug it much faster, and therefore ship it faster. So I wonder if the next set of models will push me back towards TypeScript, because I'm almost having to review the code less. But I thought it was interesting, the languages that it kind of points you towards the capabilities of these models.
Yeah, I saw an interesting tweet where it was like, I forgot what it was, but it was basically talking about that. And sort of like one thing that I said in relation to that is, it's like, if you look at the history of coding, right? Like, you start off, basically, what was like way back in the day, it was essentially punch cards, right? And then you have sort of languages, super low level languages, C being developed, assembly being developed, and like those languages, just due to the, sort of computer restraints, the actual sort of syntax was 2 letters, right? You got JL, like, and like, and it was just because literally the size of the file was important, right? But then it's like, you fast forward 10, 20 years, that's been abstracted. Like, obviously in assembly, you can have direct control over the registries, direct control over data allocation. But, as you, like, let's look at Python now, like, if you were to do like the most optimized piece of Python against the most optimized, like same script, just like, a while loop or something like that, right? Python's going to be less performant, but faster to write because it's closer to plain English. I think this is just a natural progression of this, right? Like it's just even more abstract. One thing, and I'd like to get your opinion on this, and this is something that we kind of go back and forth with at BenMore all the time, is it's like, yes, is this next layer of, agentic coding, is it just an abstraction where it's like, well, now we can just write code in plain English, but the logic stays, right? Sort of the know-how of like computer systems and like how to, define logical sort of mechanisms and sort of business logic in your application. Is that still going to be needed? Or is it literally going to get to a point where it's like sort of that level of the logic itself can be delegated to the agentic workflows? I would like to hear your opinion on that. We don't really know at BenMore, and maybe it's coming, maybe it's not, but I
think it's very easy to say in the long run, all technical know-how doesn't matter because AGI or ACI or whatever you want to call it kind of takes everything. But to quote, Milton Keynes, not Milton Keynes, one of the famous economists, in the long run, we're all dead, right? So actually, I think right now, right, you and me who have a certain level of technical background, you can produce, call it 10 times the amount of code, 10 times the level of output as we could call it a year ago today, very roughly. But if you give the same tools to people who don't have any technical know-how, they're not producing these fantastically capable systems. They're not producing working apps. They're not producing, call it amazingly profitable businesses. Mm-hmm. And the question is that a solvable problem where you just create an AI system that kind of understands what you mean generally and then produces what you want? Or is it really a fundamental kind of information density problem that we just know how to impart to the AI, this is what I want, this is exactly how I want it to be implemented, this is exactly how I want it to look, this is the UX I'm kind of imagining in my mind, here, go and do it. I think probably now I'm talking about this, the future probably looks very much more like everyone becomes a project manager rather than everyone becomes a software engineer.
Well, and that pegs a question, right? It's like, let's say that sort of technology is delegated where you could independently have an agent essentially identify a business problem and then develop a solution and then run said business. Then at the foundational sort of AI like Anthropic, why would they release that why wouldn't they just use it internally, right? Why would they let anyone else have access to that, right? Why wouldn't they just essentially monopolize and spawn army of people who can, or people, agents who can identify business problems and just make businesses, right? Like that's business use case. So it's like, even if that technology does get developed, is it, if you're looking at this purely from like a profit lens as one of these AI, master AI companies or, sort of these, foundational AI companies, it is the best sort of monetization opportunity, like letting that go out, for people to use and charging a margin, or is it just to keep it for themselves and then essentially just start disrupting every single industry that's ever existed because you just have an army of people at that point, essentially? I don't know.
The problem with that thesis, I think, is that we just haven't, and I don't know if we will ever see kind of like a totally breakout success from one of the labs. Every time there's a leap forwards, GPT-4, Opus 4.5, Sonnet 3.7, like all of these kind of ones that live in our mind as like, that was a huge leap forward. The other Western AI companies catch up within like a week to a month, and the Chinese open source models catch up within like a couple weeks, 2 to 3 months, right? Exactly. I don't know if this is like a San Francisco rumor mill thing, or just like the desire to be published, or what. But there doesn't seem to be like a huge technical moat between these big model companies. If there
is one company that's running away with it right now, it would be Anthropic for sure, at least in my opinion, for most use cases. But think about exactly.
Think about, people have really short memories in AI. Think about in November when GPT-5 had just come out, Codex was better than Claude Code. Everyone, including Elon Musk, pull up the tweet. He said, winning was never in the set of possible opportunities for Anthropic. everyone said Anthropic's dead. They had to have this big company offsite to like raise morale about their prospects. And now everyone is like, Anthropic is the best. They're winning everything. Look, I'm wearing an Anthropic hat. I'm a huge Claude fanboy. I always have been. But my position remains that the gap between the top model companies is not that big, and it will continue to sort of trade places over the next few years. And should we see some kind of super intelligent or artificially capable intelligent system that can go out and act on the world, and we have this like country full of geniuses in a data center, I think that we will have multiple competing companies, and that will probably drive them to release it.
Yeah. I think in Dario's most recent letter, he sort of outlined that is where he sees things going. Like he used that analogy, sort of, country full of geniuses in the data center. Now, one thing came to mind though, is it's like, but let's talk about the processing behind these models. I obviously just know NVIDIA. I don't know if it's that equal on the sort of, hardware side of things, the engine.
That's a very fair point.
Yeah, is NVIDIA just kind of running away with it? I don't know. I know NVIDIA, AMD, but I think NVIDIA's kind of been the golden child in that sense.
NVIDIA is obviously the golden child. I think there's a Jensen's book is right there. But NVIDIA has been amazing, obviously, hence the $4 or $5 trillion market cap. I haven't looked recently. But we've seen inroads from TPUs at Google. They bought out Grok because of the success of the language processing unit. And that's not necessarily the sign of a company that feels that they have this sort of uncrossable technical moat. That's a sign of a company that is paranoid that they want to stay ahead consistently. And obviously microchips are an impossibly complex business and supply chain that whether we see like some completely new player seems unlikely. But again, I think that the TPUs from Google will continue to get better and play an increasingly important role. And potentially some more of these startup companies could be making inroads into the NVIDIA monopoly.
Got it. Well, so let's talk about the, on sort of that sort of competitive landscape. The other Jeani that was just launched, Jeani, the world gen model, that is one thing that I do think, if we're talking about like sort of the different, I do think that we're starting seeing some verticalization of these companies, right? Like, do you think Claude Code and Anthropic is, I know they were doing image gen for a little while. I don't even know if that's in their platform anymore. Definitely seems like Google's going more sort of down the creative route with world gen, image gen, video gen. OpenAI's kind of been all over the place. I know Grok also has a very decentralized sort of service offering. But, your initial thoughts on, Jeani, the world gen model. I don't know if you've had a chance to play around with it or what your sort of initial, thoughts have been on that in terms of the capabilities there.
The thing about Google DeepMind is that it's run by Demis Hassabis, right? And as much as he'll hype up Gemini launches and kind of play the part, I don't think that he fully believes that LLMs are like the final paradigm. In the same way that Sam Altman, it seems like he really believes that. Dario also definitely seems like he really believes that LLMs are it. Demis seems much more focused on traditional approaches, reinforcement learning schedules, and kind of building up a generally intelligent system. And so that's why I think that Google's advantage in world models is, I think that's probably a driver of it, because there's Jeani making the world models, and the other one is coming to mind is Isomorphic Labs, which was spun out of DeepMind. But Isomorphic Labs is essentially trying to simulate an entire wet lab on a computer. Then
what is a wet lab?
A wet lab is a laboratory where you can conduct biological experiments on like actual biological matter.
Oh, okay.
And so if you could simulate that? Yeah, they're trying to simulate that on a computer. And if you could do that, obviously you can run trillions of experiments at once and make the kind of scientific breakthroughs that these AI leaders keep talking about. And the same thing kind of applies to world models, right? Like I think about this all the time. We actually try a lot to collect simulated data. Like it would be amazing if we could just have, hundreds of thousands of virtual people walking around with virtual genies on. Sorry to mix the genies,
genie,
but hopefully people know where I'm going. But if we could collect, huge amounts of simulated data and train models on that, that is where you start to get this sort of idea of a takeoff. And I think probably the world models is an important factor in that. We know that spatial intelligence in language models is a problem. We know that kind of their understanding of physics outside of the mathematical concept, they're pretty good at maths now, but their understanding of real world physics is still lacking a bit. And that's the kind of problems that world models could really solve.
Right, almost a training, just a sandbox environment for, you can do, you could do self-driving car training, you could do robotic training, basically
famously Waymo does that, right? Like
really, they do.
Waymo's huge part of Waymo's advantage is that they said, we can build a virtual San Francisco and we can drive 100,000 miles in the simulation for every mile we drive in real life. That people underestimate how much simulated data is already playing a part in real world AI systems, and Waymo is the golden child of that.
Are you serious? That's why they have been running a lot of training in simulated environment. Wow.
Huge amounts.
That's incredible.
Huge amounts. Yeah.
Wow. And clearly the proof's in the pudding with their
Absolutely.
Wow.
The data from Waymo is very clear. They are the safest driver to ever exist.
Jesus. Are you serious? Wow, that's incredible. And so sort of the generation, and if you were able to do that on a biological level with wet labs, like you're saying, you're kind of opening the floodgates for almost one of those, not to, tie this back into pop culture too much, but like one of those like Black Mirror episodes where, a character just finds out that they're one of a billion concurrent simulations, and also pegs the question, not to get too meta, but like, what does that mean for our reality right now? What if we're a data point kind of getting.
Do you think that the emergence of intelligence in the way we've seen it, in that it's like, it seems to be mostly a scale thing, and kind of the problems that we're running up against in terms of like the data wall and how simulated data does seem to be like very important in these feedback loops, it does sort of maybe change the calculus on whether like our reality is real. I haven't thought too much about it, but
it's one of those things
probably it probably moves the needle a little bit in the direction of maybe we are a simulation.
It's one of those things where it's like if we get there, we get there.
Right. Exactly.
You probably just worry yourself the entire time thinking about it, but it's still interesting to think about. I'm interested to hear this segue me into sort of you have a background in neuroscience as well, and if we're talking about sort of LLM mapping, and one thing that I've always thought about is like to what extent you're saying that Dario, Sam Altman, they kind of see LLMs being the final frontier. I don't know if you've looked into the mathematics behind LLMs. I haven't, as much as I would like to. But to what extent do these systems map the human brain? In your, background in neuroscience, what is the crossover between what we're seeing with LLMs, with developments in AI? Where does that sort of tally up against the way that the human brain works from a neurological standpoint? What is different? What's similar? And can we get to a point where it's essentially mapping the human brain in the way that we process data ourselves as biological people?
There's an excellent recent Dwarkesh podcast episode about this. It's like an hour long, but it's really in depth, and it does go into the sort of bigger questions around what are we doing in terms of similarities with the human brain versus not. I'll start with, I guess, the similarities. Neural networks are kind of a loose abstraction of how neurons fire as different systems in the brain. That would be kind of the biggest similarity. The other big similarity is that as you scale up models, you see huge gains in intelligence. That's the scaling laws summed up roughly, right? The same is true in intelligence that we've observed in the world, right? We have the biggest, it's called encephalization constant. We have the most brain matter compared to the size of our body. Because obviously you have certain amounts of neural mapping that just controls, motor movement and stuff like that. So elephants and dolphins have bigger brains than us, but they're also in general bigger than us. Precisely. And so intelligence seems to correlate with how much sort of, I guess, spare brain you have. And same in LLMs, as we scale them up, they get smarter. The difference is, the obvious one is we're not doing next token prediction. You can kind of make an argument about whether LLMs are still doing that, but the fundamental technology was that, right? Was next token prediction. We're not doing that, at least on the language.
So people do not do that. They do not just try to predict when they speak. They're not just doing that. That's something that's on my mind. Is just like when I'm talking to you right now, am I essentially writing a prediction on like what the next word out of my mouth should be? So we are not doing that.
Well, this is the thing. We don't necessarily know, right? Because consciousness is a very sort of murky topic in neuroscience. I'll tell you what, that book there, the one next to Jensen's book, is all about consciousness as well. There's a whole book about it. I've read it, and it's still a bit murky. It's called Being You by Anil Seth, professor, obviously, Anil Seth. But whether we do next token prediction, we definitely don't do it on the language basis. We're not just like saying this is the next word. Whether we're doing that at like a meta level of
like
kind of, we're taking in all of these different stimuli and then predicting what happens next in terms of, there's some evidence we do this in vision, right? Like there's all these kind of like visual hallucination things,
and
right, where you can
like our eyes, and we like block out the
we regularly get tricked by visual hallucinations because we think something's there that it's not.
That's so funny. Literally movement, hallucinations,
right, exactly,
due to essentially our brain trying to predict and fill in
movement. You often like trip because you've kind of predicted that the height of the next step is going to be a certain amount, but you've got it wrong. So there's a lot of prediction going on. There's one theory that the cerebellum, which is about here, if you go into the middle of the brain, right at the bottom, there's some evidence that is doing sort of global next token prediction about like all these different stimuli. What do I kind of expect to happen with the world? But it's pretty shaky still. The neuroscience has like a long way to go to being a solved science in the way that like even a partially solved science in the way that physics is. I have a lot of hope actually that AI research will help this, because the more we can kind of stimulate neurological systems, the more we can go in and kind of poke around and see what happens. That's not as easy to do on human brains, right? It's actually very much frowned upon to go into people's brains and like start just cutting things out and see what happens.
Can't do that.
Yeah. So there's a lot of similarities, a lot of differences, but I think that they're good sort of mental models for each other.
So it seems like right now, and I don't track Neuralink at all or any of these sort of like, implant technologies, but it seems like right now most of that research has been focused purely on the functional side of things, right? Essentially plugging into a component of your brain where you can control, sort of things. And that seems to be, and correct me if I'm wrong, but that seems to be like the lowest hanging fruit, the easiest sort of place to enter in, because those are essentially mechanical signals, right? And if you can interpret and then sort of, derive and, push those signals elsewhere, into a computer interface, that's low. How, and I'm sure it's extremely complex, but, is that kind of what's going on with those interface? They're essentially attacking like the motor skills and trying to extract that into technological sense.
I think there's two reasons. One is that there's huge impact that you can have, right? Helping people who are paralyzed sort of interact with the world again. That's a huge impact on the world you can have. It gets people very excited. That's like a huge mission driven thing. The other is that there's a really good feedback loop of whether you kind of are able to pick up the glass or write something or things like that. The other things we're seeing is brain-computer interfaces, right? There's like these examples of people playing video games like with their minds. And again, it's kind of like because there's a really obvious feedback system. Whether we see them, I guess, Neuralink and these other companies attack different problems, I think we'll see about how successful they are at these lower level tasks. The thing about the brain is it's just unbelievably complex.
Yeah.
to the level that is almost incomprehensible.
Yeah.
I think like there's just the level of complexity that's going into me talking right now.
Yeah.
It's pretty hard to comprehend that. And so simulating that computationally is hard enough, let alone sort of replacing it.
Yeah. Yeah. But as you mentioned, perhaps some of these experiments and simulated data can help expedite that process. At the very least, sort of the feedback loop and sort of interactability will be expedited probably by a factor of in the millions if you're able to simulate, experiments. Okay, well, sort of moving on from that, let's talk, last couple of topics here. Let's talk about Duke, how your experience has been at that program, and then we'll talk lastly kind of about, the future of Jeani, talent acquisition, which you guys are trying to do down the line. So, Duke, obviously we went to school together at BU.
Certainly did.
How's your experience been at Duke? What are you excited about? What are you learning? What are you focusing on? And yeah, I guess kind of on a macro level, how's it been over at Duke?
Was well sort of orchestrated by the program, and I've got nothing but good things to say about it. Particularly, I found here the interest in working on problems in mechanistic interpretability. So having ways of understanding language models is really good.
Interesting. And
it's an immensely complex world to try and keep up with the research in, but they do a very good job here.
Interesting. And so I guess moving forward, let's talk about Jeani Health. So it's a team of 3. Talk a little bit about, your co-founders. How did that kind of get started? How did you guys meet? Where did the idea come from? And then also what you guys are looking to do here in the immediate future in terms of raising. I know you guys just launched as well. What do you kind of see the outlook for? But let's, start first and foremost with, the core team essentially.
Yeah, so it's me and 2 other guys who actually both live in this house as well. We're all on the track team, so that's how we met. We've got Ewan Bradley, whose his academic background was in human biology, and so we do a lot of work together on what does the research say about biomechanics and injury and what that manifests as. And how do we design models to actually pick up these differences? And then the other founder is Michael Bennett, who is the other side of that wall. But he's in the business school here and very sort of in the network of professional sports and particularly runners. And so kind of designing products and experiences that people actually want to use, right? As well as anyone else, you could design the coolest technology in the world, but if it doesn't work in the way that people want it to, it doesn't provide a level of interest that people are looking for, then it's essentially useless. And so he does a lot of work on that side of things. We have a really great setup, being able to live together because problems come up, we talk them through kind of immediately. Not to be like, oh, we do 996, blah blah blah. But we work pretty much continuously throughout the week.
School too, which is you guys got.
Yeah.
I assume it's school, track, and this is probably your entire.
Right. There's lots going on, but luckily, they all kind of help each other, right? And so I'm having the most fun I've ever had in my life. So that's I think that's what you have to aim for, right?
Yeah, absolutely. And then, so you're graduating here in the spring, right?
Yeah.
Coming up. And then you plan on taking this on full time, if I understand correctly. And so what does that look like? Full time, first time in your life probably ever without school or track. Are you guys making a move to SF? Are you guys staying in North Carolina, New York? Are you guys looking to raise? What's the immediate timeline here coming up in the first half of 2026 and going into the second half as you guys essentially are, in the, this is essentially your only priority.
Kind of get to work on them, right? We need more access to compute so that we can make bigger and better models. We need the ability to kind of design and build our own hardware so that the user interaction makes a lot more sense intuitively. And we obviously need to keep the lights on, but that's.
And are you guys planning on going full founder mode, ramen, splitting rent in a 1-bedroom? And is it the sort of almost what's become the San Francisco dream? Is Is that aligned with you guys? Are you taking a more, what's sort of the sentiment between you guys as you make that move?
So I've thought a lot about this. I think that yes, we will be doing that, but employees will not be expected to do that because we are a health and wellness company, right? Yeah, so it doesn't really make sense for us to be, it doesn't really make sense for us to be like killing our employees, right? And actually, I would, I would very much encourage people who work for me to sleep 8 hours a night, eat well,
make sure your movement's good too.
Make sure your movement is fantastic, right? You're a mental athlete, right? That's the way I view it. And so I want you to be at your peak. That's why I'm paying you, right? So that's the view of Jeani Inc.
Yeah, that's awesome. Last sort of segue here, something came to mind, is the sportification of technology. You talked about your, essentially the people who who work for you essentially like being athletes. I definitely take that approach. We're seeing almost a sportification, especially with TBPN coming out now. Obviously, you'll see the overlay here. We're definitely taking that approach here as well.
Nice.
What's your opinion on that? Personally, I love it. I think it's much needed. I think there's also, just from a business perspective, I think there's obviously been massive capitalization on the outcomes of technology companies. I don't think there's been little to no capitalization on the entertainment, sort of the sports and competitive nature of technology companies. Is that something that you're seeing? And what is your opinion on the sportification of the technology industry?
I think it's just fundamentally downstream of the talent dynamics, right? Like, kind of the previous era of technology, what you needed was people with really creative ideas and kind of like an ability to be very process oriented and very, very hardworking, and then also kind of like have a creative spirit. And I think you see that in kind of like call it like Silicon Valley, maybe not 1.0, but like 2.0, right? Like the stories you hear of like Instagram and like, early Facebook, maybe even, or early Google.
Like Google, yeah.
Right, exactly. Now, what we've seen in the AI era, and let's just base this purely off of like comp structures, you're now looking at like the marginal like amount you're spending on the next like level of talent in AI is kind of unbelievably high. We're talking like billions of dollars in the case of Meta Superintelligence. And that's the same pay structure we've seen in sports
like
forever.
Yeah, athletics, right?
That's what we've seen in basketball, in football, soccer. That's always been the case.
Yeah, I mean, you see these $50 million deals getting signed, right. People getting traded between companies, like their teams.
Exactly, and so I think that then lends itself to like a sports-like entertainment structure. Now, my two big passions being technology and sports, I think it's the best thing ever.
It's so electric.
Yeah, I think it's amazing. There's probably many people with different opinions, but that's my feeling.
That's definitely my feeling as well. And I do think, especially in the age of agentic coding and sort of just agentic, just productivity in general, the level of productivity that an individual can contribute to an entire organization has heightened as well. You have a top performer who's a 10x developer weaponized with agentic coding and an expert in that. You could make the case, and they can be outputting the, previously the level of entire team structures. Previously it's really coming down to almost individual, like you mentioned, that individual level of contribution has exploded in the past really couple years. I would say not even 5 years, but really couple years. And so you can sort of, you can make a case for $50 million going to an individual, $50 million, $100 million over the course of 5 years going to an individual. If they are going to come into your organization and develop frontier level technology that will, and they can do it, with a smaller team and bring in 10 times what you're essentially paying them. I think that we are seeing that now, and it's led to like this massively competitive. I saw this one interview of TBPN where they were in front of the stock exchange, I think, and they had Satya literally wearing like a sports cap, like a NASCAR driver, and I was just like, this is, again, we're both athletes, so right, like of course we're going to be biased towards this, but I was like, this is the coolest thing ever, right? And we're going to say, I guarantee you, we're going to see sorts of commentators like the tech equivalent of Stephen A. Smith come out with just these opinions. And I do think we're going to see media networks. I think TBPN is one of the media networks that we're going to see specific. I mean, I would say here at Benmore, one thing that we're going to do in the next month is we're going to get a TV, and in our offices, we're going to have TBPN playing in the background 24/7. You know, we're kind of creating that competitive environment. And also, I will say, with that sort of level of output, this is just more internal at Benmore, that's definitely something that we've seen here as well. We have individual contributors that can directly bring in sort of, and they are, you know, we have performance metrics, but really it's almost going to sort of a team structure where you have GMs and, you know, coaches and stuff like that. And you're essentially, it's predicated around the talent, because talent, the gap of talent, and the productivity gap between an extremely talented person. You know, people always said you can't overpay for talent. I don't think that that's any more true than right now. And honestly, I don't see that's going to change, at least in the next, you know, year or two, until maybe if we take the claim that these AI models are able to do a lot of these tasks independently, well, then it kind of, you know, the whole paradigm changes there. But as of right now, it's extremely like on an individual level. So it's extremely exciting for us here as well.
Yeah. No, I like, speaking of talent, you know, what we are kind of looking for when we're kind of hiring people is changing so drastically as these kind of model capabilities change. But I would say that right now, what we're looking for, which we maybe weren't looking for, say 3-4 months ago, is sort of super committed generalists. So people who are very capable across the board.
The idea guy. That's blown up on X recently.
Right, the idea guy, but also I don't think that the idea guy and the execution guy are different people anymore. I think they're the same guy.
No. And if anything, the rise of forward deployed software developers have kind of, you know, that role itself it's really kind of combining it. So you have literally the role of a forward deployed software developer is functionally to be the idea person and the execution person.
Yeah, precisely. Yeah,
exactly. Well, anyways, anything you want to shout out? Any upcoming releases? Anything, you know, people should look out for in Q1 or the first half of 2026? The first half of the 2026 season, you know, any big moves that you know, you guys over out of North Carolina will be making, you know?
Yeah, well, definitely, if you have an Apple Watch, go and download Jeani for Apple Watch now. You can try it out. We're actually giving it away for free for the first month. And then if you have a Garmin, watch out for that release. That'll be coming soon. And in terms of more like sports style news, I'll tease that, you know, we're looking at training another foundation model within the next sort of 2 months. And I'm hoping that will completely blow our current model out of the water. So yeah, that's the lay of the land.
Awesome. Well, Stuart, thanks for hopping on. I'm sure I'll see you in the next couple of weeks.
Pleasure for coming on. Thank you for having me.
Recurring personality as we build this. But yeah, thanks for coming. I'm going to stop the recording now. So.
Awesome.